Now we're going to look at our last axis, our hypothalamic pituitary mammary axis, which is going to be secreting prolactin for breast milk, and also we'll look at growth hormone, and growth hormone, as you can see, influences almost every single cell in our body. If we start talking about the mammary glands, we're going to influence the amount of milk that's produced through this hypothalamic pituitary prolactin axis, because prolactin is the end result hormone that we're going to be looking at. So just like everything else, we're going to start in the hypothalamus, and we're going to make a hormone called prolactin releasing hormone, or PRH. And that PRH is going to be secreted out through that hypothalamic hypophyseal portal system, and it's going to go to the anterior pituitary gland, and that anterior pituitary is going to put out prolactin. And prolactin is going to be the hormone that is basically going to be producing milk in that mammary gland. Now, what's interesting to note here is that the mammary gland itself is taking that milk. So here are all these little mammary glands, and they're taking that milk and they're excreting it. So this would make the mammary gland an exocrine gland. But everything leading up to it has been endocrine. The hypothalamus and the anterior pituitary are both endocrine because they're putting their hormones into the blood. Prolactin is getting it out of the body. Not quite as simple as that. We have our prolactin, but we also have something called prolactin inhibiting hormone. And if you think about it, women aren't producing milk their entire lives. It's only really during pregnancy and right afterwards. So this prolactin inhibiting hormone is really dominant, and it overrides all of the prolactin releasing hormone. And this prolactin inhibiting hormone is something you've heard before. It's actually just dopamine that it's releasing. And it's releasing that from the hypothalamus to the anterior pituitary gland, and it's going to inhibit that prolactin until pregnancy. And what happens in pregnancy is that you're going to get this little surge of estrogen, and that estrogen is going to cause some milk to be produced. And we'll see that during some of the early and middle months, or even later months. But once you get a lot of progesterone and estrogen together, it's going to kind of halt that, and it won't be continuing to make milk. And so if no more milk is being produced, then it's after parturition, and parturition basically is birth, then the estrogen and progesterone those levels drop off, and it's going to allow this prolactin to be really active and make all that milk. And that's when the milk, with the common term of the letting in, the milk is letting in, that's when the breasts really fill up largely with milk in those first couple days right after birth. At the same time, hormone that it works with is called oxytocin. And we've heard of that a little bit. You might remember it's released from the posterior pituitary gland. It's made in the hypothalamus, but those direct neurons coming down release the oxytocin into the blood. And the oxytocin is responsible for milk ejection. So prolactin makes the milk, but it works together with oxytocin to eject the milk. And one of the strongest reinforcers of those is something called a suckling reflex. And the suckling reflex occurs when the baby latches on and starts saying, "Mama, I want some milk." And then both of those hormones are released, and mom's going to make more milk and make more oxytocin to eject that milk. And this can happen by physical stimulation or actually just emotional or visual stimulation. I remember when my wife and I had our first child, and several weeks went by and everything was going fine, but we just needed a date together. And so we got Granny to come over and watch our baby for a couple hours while we just went out to a simple restaurant for some kind of food. And we sat down, and lo and behold, in the table next to us, or a couple tables away, there was another young couple, and they brought their baby with them. And the baby was crying for the mama's milk, and that got my wife's emotions going in her brain, and that caused her to let down oxytocin. And as a result, she leaked all over the front of her blouse, and that was the end of our dinner. But so you can have a physical or emotional response to this, and that's going to play with oxytocin, which we'll see also is an important hormone that's released after sex in both males and females for cuddling. Okay, so that's the mammary glands. Let's move on to growth hormone. And growth hormone, like everything else, starts in the hypothalamus. So we're going to have this hypothalamic pituitary growth hormone axis. So in the hypothalamus, we're going to release something called growth hormone releasing hormone, because it's going to be releasing it from the anterior pituitary. So that GHRH is going to come down through that hypothalamo-hypophyseal portal going to the anterior pituitary, and that anterior pituitary is going to release growth hormone. And this one is pretty straightforward. It's going to go to your bones, muscles, and tissue. So we'll see that right here. It's going to really, that growth hormone is going to reinforce all the strength and growth. You've got growth hormone receptors on just about every single cell of your body. So every cell is going to respond to this growth hormone. It's going to promote the movement of fuels to getting to those tissues so that they can grow and survive much better. There are a couple of conditions associated with growth hormone. If we look at them, dwarfism is basically having not enough growth hormone as a child. And dwarfism is really caused by autosomal dominant mutation. And it's not going to allow, actually there's going to be a few different causes for it, but mostly it's caused by a condition called achondroplasia. And that means that the chondrocytes are going to be deformed, and it's from the chondrocytes that grow into bone. So they're not having enough bone growth throughout their whole body. You'll see that dwarfism is defined really as by somebody who's 4'10" or less. But everything else is operating about them just completely normally. On the opposite extent of that is we have giantism, and that's when you have too much growth hormone as a child, and that's going to cause all of these cells and bones to grow extensively, and you can get upwards of 8 feet or more. For those of you that saw Princess Bride, Andre the Giant was somebody who had giantism, and even after his epiphyseal plates closed so that he couldn't get any taller, most of his growth was probably done by junior high as far as height goes. His body still continues to grow, and his face continues to grow, and his hands and everything, all of his other soft tissues continue to grow, and that's going to contribute to giantism, and they actually have quite a few problems later on in life. If you're fine, if you're normal as far as growth hormone goes, as a child and when those growth plates solidify, but later on in life, if you start secreting too much growth hormone, you can have a condition called acromegaly. And this is too much growth hormone as an adult. Your long bones aren't going to grow anymore, but a lot of bones around your face and in your hands and in your feet, so let's write this here, face, hands, and feet, continue to grow. And a lot of people think that some very famous people, Abraham Lincoln, just from pictures of him, we think that he may have had acromegaly, or another governor, Governor Pico. But it can also cause problems with your heart, and colon can be related to some different colon cancers by having too much growth process going on after you've reached maturity. And that, I believe, is going to be the end of our section on growth hormone. Thanks for watching, and tune into the next one. Bye-bye.